All right, so you have a graphing calculator for this test in the testing platform. So you should graph the function to see what it looks like. This one will look like this. And since the function is symmetrical with the y-axis, this vertex goes right through the y-axis here, the graph has even symmetry. It's a parabola, so the domain is all real numbers. And you'll notice on your graph, the lowest y value is going to be this transformation down 5. So the range is from -5 to infinity. Another way to write that would be y is greater than or equal to -5. Left end behavior, x goes to negative infinity, y goes to. So as x goes out to the left, the y is going up to infinity. Right end behavior, x goes to positive infinity. So as the graph goes out to the right, the y goes up to y approaches infinity. All right, for B, go ahead and graph that in your calculator. We're going to note that the top y value is at 3. Again, this is even symmetry. We have this y-axis symmetry. Domain is all real numbers. Now the range, we start at the bottom, that's negative infinity, and stop at the top y value of 3. So you start down here and you travel up to the top. In inequality notation, that's y is less than or equal to 3. End behavior left, end behavior x goes to negative infinity, y goes to. So as x goes to negative infinity, y is also going to negative infinity. Right end behavior, x goes to infinity, y goes to also negative infinity down on the right. All right, last one, x to the third. Graph that in your calculator. And now this graph has origin symmetry. If you rotate your picture completely upside down, 180 degrees, it is the same picture. So that is odd symmetry with the origin here. The domain is all real numbers. The range is all real numbers. Left end behavior, x goes to negative infinity, y goes to, out to the left. The y is going down to negative infinity. Right end behavior, x goes to infinity, y goes to, out to the right, the y goes up to infinity. All right. Select the transformation that is attained from reflecting across the x-axis. So reflection across the x-axis makes the y negative. So that is a negative in the front. So not C. Yes. Okay, so that can either be A, B, or D. So now I've got 3 choices. So that's a negative coefficient in the front. Then a horizontal dilation. Horizontal is on X, so that's not B, of 2. And everything with horizontal is, the way I kind of like to think of it is it's opposite of your common sense. So to the right would be X minus a number. To the left is X plus a number. So for a dilation, I didn't mean to cross that out. I meant to underline it. For a dilation, the coefficient or the multiplying value is the reciprocal. So I'm going to look for the 1/2. That's not A, that's a 2. So the answer must be D. Now we're going to select the transformation. That is a vertical dilation of a half. Okay, vertical is in the front. Okay, whoa, look at this. So I don't like the way A is written. I'm going to rewrite this as negative 1/2 f of x. Oh, that's the same thing as B. Okay, well, we'll get back to that. Maybe there's going to be 2 right answers on this one. It's not C because that's the x divided by 2. Okay, reflecting across the x-axis is a negative coefficient in the front. So that would apply. That would apply. Not that one. So I guess this problem, the way we accidentally typed it, is there are two answers, A and B. Unless, is that a smudge? No, I guess it's just an extra negative. So there's two answers. On the district test, there will only be one correct multiple choice answer. I'm going to fix that in the handout before we pass it out. Okay, for 27, now we've got reflecting across the y-axis. So that is if I'm at x here, across the y-axis is a negative x. So that could be this one, not that one, this one, or this one. All right, so 3 choices out of the 4. Shifting 6 up. So up 6 is adding 6 at the end. So this transformation is left or right. It's not that. Here's the adding 6 at the end. The answer is B. Definitely not A. That's down 6. Not A. All right. Jack wrote the equation for the piecewise function, but he left off the restrictions here. Complete the equation. All right. I see a line. So that's this piece, linear. And that part of the graph exists for every x less than 0. It's not equal because there's the open point at the y-intercept here. All right, the right piece, this looks like a part of a parabola, and that exists for every x greater than or equal to 0 because of the closed-in point. All right, 29, oh, we got a line again. Now this piece is the line here. And the x cutoff, that's at -1. So the line is for every x greater than or equal to -1. And then this piece must be the parabola piece. And that is existing for every x, less than -1.